go.
Yeah,
Okay,
so
yeah, the last item that I have on the agenda is Artemis 2. So I was holding things to make sure that you were back. Um,
thank you.
yes, no. So Artemis 2, there's a number of amateur sites and folks that are involved. And I think last week you mentioned that the list had been published. So 34, 35 different sites and people. And it turns out that a friend of mine in SBMS was also picked as one of the sites. So Loretta Kane is a microwave enthusiast and was also selected. So joins the list of like AMSAT DL, Bockham, and DSES that Rick volunteers at, and Dwingelo, and all of these big, very large dishes. And then there's Loretta and a few other folks with somewhat smaller equipment. She's got for an amateur, it's a large dish. But anyway, I reached out to her and asked her, hey, how's it going? And lots of good conversation. So I'm looking forward to kind of helping answer questions or um,
Yeah.
collaborating with her as well. And I'm wearing my Artemis 2 shirt.
Oh,
It looks like it's just a ordinary shirt. This is it's from L3 Harris. So you can see it snuck in the L3 Harris logo. And scattered in and out is little rockets in here. Let's see if I can find one for you guys. All right, well, this all something I'll have to stitch in later because they're kind of subtle. Anyway, wearing my rocket shirt. Now, unfortunately, the launch has been delayed.
so first I wanted to say I did obtain a Libra SDR.
Oh, very good.
So
That looks
I'm
familiar.
soon, when I'm done with Artemis, I'm going to play with you.
Very
The,
good.
the bad news is they would only sell me one.
Ah, yes.
So maybe, and they said they only had one left. So
Well, I can tell you something about that because
I think
when we
they're
bought the
always
last
got
batch
only
of
one
Libre
left.
SDRs, it said limit one per customer.
Yeah.
And so I bought one and I made some mistake in going through the procedure of actually checking out and ended up buying another one. So they don't enforce that limit.
Good.
You can get
So
more than one.
I'll go back and buy a second one because one is useful, but because my spectrum analyzer is repaired, so I can at least transmit and look at the signal. But I'd like to have a pair, so we'll get around to that. So back to Artemis. First, let me share. I assume I can share.
Yes, yes, you can.
Uh, 2 hours ago, I got this official message from NASA. I am the point of contact for DSES, and it said, we are done with February. Forget February. We're now going to launch in March. So it's not just a little delay of a couple of days, it is a month. Uh, and that's probably a good thing for us. But here are the launch times and launch dates in March. And of course, if they don't fix that hydrogen leak in time, it'll slip out to April. So then I wanted to show you what we have done. I was there Saturday and installed this equipment in the right-hand section of our main science console at the DSES site in Haswell, Colorado. And this equipment here is described in detail on a new web page under DSES.science, and it's under projects, precision, time, and frequency. So we have now got all of this equipment in the far right rack. Was donated by various entities and is up and running and producing high precision time and frequency. What that is 10 megahertz signals at approximately a couple of parts in 10 to the minus 12th, and a high performance NTP server that's providing time at about 100 microsecond accuracy to the other computers, which are going to be collecting the Artemis 2 Doppler data. So to see, oops, oh, there it is. There is the entire console as it exists right now. The Center 2 monitors are attached to the computer that is listening for the Artemis. The signals that are being shown on the left monitor are coming from our beacon that we have in lieu of Artemis itself for now. And the RF equipment is in the next rack to the left, and the far rack to the left is the antenna steering computers and other antenna steering devices. That's me trying to get the software to work. That's always a challenge, no matter how much you prepare. This is my son, who was responsible for the design of the NTP server on the left, and Ray Ubrekin, who's been my partner in crime in all things rubidium and fixing the spectrum analyzer and donating various designs to make all of this stuff work. That's a close-up of the rubidium on top, the GPS receiver, I'm sorry, the time interval counter, then the GPS receiver, then the 10 megahertz distribution amplifier, and then a shelf on which in the back are our NTP server and frequency multipliers and other fancy stuff is stuck in the back. You can't quite see it. Another view of our command center. Outside of these windows is the 60-foot dish. Another close-up of the equipment. There's the, on the left, the antenna steering equipment, and on the right is the RF distribution equipment. And these are just some other random pictures. Okay, I guess we got through all of those. So you can see we have been hard at work on that project to the exclusion of this and other projects. But we're making progress.
Yeah. Well, I mean, there's some urgency with Artemis, or so totally understandable. The launch isn't going to wait. It might be delayed, but does the reprieve give you some help in the scheduling challenges that you're having with getting
I
folks to
believe
staff
I
it?
believe it's a mixed bag. I some of us would just like it to be over.
Right. Yeah. Yeah.
It's a volunteer effort with no funding. I think we could have gotten funding if we'd asked for it, but we didn't ask. So there's a lot of out-of-pocket expenses for myself and other members of the DSES community. And I'm going to use the extra time to confirm that the precision time and frequency assets are working correctly, and to recalibrate the rubidium, which I need at least a week of data collected to do that, and to publish the information about the calibration on the website. So both Artemis 2 and Precision Time and Frequency have web pages under projects, which is in dscs.science. They're new pages that I just put up, and so I encourage people to look at them, and I encourage you to go back and look at them because I'm going to be adding data almost every few days. I'm hoping to add more data today or tomorrow. So yeah, I'll use the time productively. The bad news is this means I probably will not be able to volunteer for on-site duty during the 10-day mission. We need people on site to be managing the dish, to assure that it's steered correctly and that nothing goes wrong with it. And we need 2 people at all times for the various times that the capsule is in view during the 10-day mission. That's a lot of time. And so I was going to volunteer for that, but I have foot surgery in a week or so. I don't remember when. I think it's a week or 10 days or 2 weeks, but it's before this March launch, and I doubt that I'll want to drive 2.5 hours each way.
Yeah.
With my right foot surgery, therefore I can't push on the gas pedal. So, so
Yeah.
maybe Michelle will come here and drive me out to the site.
And I
And we
think
can be,
getting folks to actually be there in person is very important because the dish can't be steered remotely. That's just not
it's not safe. It's
not
not that
safe.
we can't do it. We can,
Yeah,
but
yeah, you
we
could,
don't
but
want to.
it's just a bad idea. I
Yeah.
completely agree. Yeah. No, it's a I I I think what you've hit a really good point, and we all want extra time, you know, uh, but the extra time can also incur a lot of stress on organizations like ours, you know, like DSES, like ORI, you know, because you could sort of gear up for something like you know, maybe equivalent to field day if field day lasted a week, and then it suddenly gets moved, and so now you have to ask people to, you know, move their schedules. You know, so
Yes.
maybe it will
We
help
only
get
have,
additional people. And your point about the rubidium is kind of a is very important because that was I remember last week you had just gotten it working, like and this was a recent donation, and when it was donated, I don't think it was working. Uh,
no,
so you know
here's
you got
there's,
donated, and then you got it working, and then you got it installed in the site in all very
no,
short order, right?
no. That's, the reality is the unit that was donated had a whole series of problems, which I've documented in great detail for those who want to know. But it was a cascade of failures that started with the main capacitors in the main power supply. The raw unregulated power supply had dried up and therefore were zero capacitance instead of two 38,000 microfarad capacitors, you know,
So did you
3,800.
get another rubidium then, or so is
So
this
the
another one that
rubidium
you
you
got?
just saw is mine.
Ah, okay. So you
Yeah, I
swapped
swapped
it? Okay,
the
gotcha.
rubidium that was under repair. uh, we found and repaired a slew of problems right up to the realization that the final problem is inside the rubidium chamber.
Oh,
And we could have fixed that ourselves, but we ran out of time.
okay. So you
So
made the swap, but now are you going to go back to the donated one and then
the
reloop it?
donated one has been shipped to
Okay,
California already for
awesome.
repair. for final repair.
But now you have time to calibrate the loaner.
That the unit that is there now is from my lab, and in my lab was calibrated.
Okay.
I want to recheck. That unit has not been unplugged in 5 years.
Oh boy.
And so it's been unplugged and plugged back in and mated it up with different equipment than is here. And so, and the data, the good news is I've been collecting data since Saturday. And I uploaded it this morning. The bad news is my Python code has decided to say, no, I don't want to work anymore.
It's always something.
Well, so then I said, oh crap, if I'm gonna deal with this, I just went ahead and said, okay, I'll do it the hard way. So I upgraded my Python to the very latest Python. And of course that broke everything. It
Now
broke
it's
even
really
more.
broken. Yeah.
So today's job is to unbreak my perfectly adequate working Python program that analyzes the data and produces the PDF reports.
Yes. Got it. Okay.
You know,
Wow.
And I said, oh, well, and I'm beginning to realize that there's no easy answers to any of this stuff. I'm beginning to understand why
Beginning.
why there are environment containers
Yes.
and
Yes.
all these things
okay.
you can
Yes.
lock
So
down.
just take it from someone who was very late to the party and resisted this with every fiber of my being. Um, Having a container like Python environments, and then they're sort of like similar to Docker, but not really. Wow, it's the right way to do it. So I'm now a
Well,
convert, and
I have,
I
I have,
believe it. A gentle touch there, though. Don't
Yep.
but like
no, I have Docker, but I don't know how to use it, and I know it's not what I need. So I'm using Anaconda
mhm,
to create environments
Not what you need
for
either.
the Python that I use locally here.
yeah,
And even that,
yeah. Well,
excuse me.
don't.
So
It will help a lot. I just letting you know, because
I was
I
tempted.
was like, I don't believe in that, because to me, old school programming language, like Python's a reasonable programming language, right? Like you should just be able to use it on a computer, and no, it's different. So
Hey, I started with Fortran and
yeah,
Basic, and I
yeah, I
never
hear
had
you.
a problem like this. You know, we didn't have any libraries. We had to write our own.
Well,
So,
I'm glad that you and I have joined the 20th century. You know,
oh no, wait. I in school, I took Basic Assembly Language for IBM 360, COBOL, RPG2, and of course Fortran, APL, um, and then afterwards it was Modula 2 and oh, and I don't know, a couple of other good languages. Some of them I absolutely fell in love with, and they just sort of went by the wayside because C and C++ was everything. And I'm still writing all of my major code in those two languages. But Python has its place.
yeah, it does.
And
No,
Absolutely
it's
does.
an interpretive, it's a slow, painful interpretive language like BASIC was. But who cares when our machines are now 1,000 times faster than they were just a few years ago? So it's okay.
Yeah.
Have
No,
you looked at UV?
What?
UV. It's another one of these ways to control your Python environment, but it's better in a lot of ways. That's what I've been using here.
Uh-oh. Yeah, bless me. I have this whole list. I'm just going to put it on my list uh, because
Anaconda is it should be considered obsolescent, I think.
I'm trying to think if UV is the one I was looking at to replace Anaconda.
Probably.
It might be.
Yeah,
I know that
take another look at it and see what you think, because
well,
it's worth it.
right now I just need to get the Python working with today and UV tomorrow.
I have
Oh,
absolutely
here,
nothing but empathy. I totally understand.
well, here's my other problem. The Artemis mission at DSES is 100% ready theoretically, except for one thing. One of the backup computer, which is Linux, uh, that will generate backup data for the mission based on a different access to the feed than the main hardware. Is 80% up and running, but the other 20% Alex needs access to it from home because he ran out of time at the site. We have been using Splashtop for remote access to our computers for quite a while. However, Splashtop changed the rules. And the new rules are totally unacceptable for organizations like ours, even if you pay for the full-blown access, which I do, totally unacceptable. I won't go into why, it's just not relevant. So I'm looking for a new way to access all of our computers, but for starters, I need to give there's two Linux computers that I don't have clean access to right now. And everyone who designs one of these puts in a different remote access protocol. So my son, when he did the NTP server on the little Linux machine that's in the time and frequency rack, he used Tailscale. And I said, okay, tell me all about what I need to do to access it. Well, we wound up breaking that computer completely and totally and having to restart from the operating system up because Tailscale and Splashtop do not like each other on the same machine at all. They broke each other really badly. The whole desktop got broken, had to be rebuilt.
Wow.
So I said, okay, we just erased Splashtop. Now my son has access, but I don't. Nobody else does because we don't know how to use Tailscale. So that's on my list. See, UV, Tailscale, fix Python. Okay. Now, over on the other Linux computer that I designed, where I'm responsible not only for time and frequency, but for the backup uh, monitoring system for the Doppler. And on that computer, I put Splashtop. Well, I gave Alex access. I found out that when he was accessing using the shared access that I gave him, then my whole company was shut down because I couldn't even access my local computer on the shelf. Because Splashtop said, no, you can only have one person at a time. And that's fine. But that's not quite how it used to work. So I said, okay, I got a great idea. I'll put Tailscale on that one. I don't know what it is, but I'll figure it out. And Paul's giving me the thumbs up, so it must be in the right direction. But wait a minute. The other computer broke really badly when I did that. And I can't afford this one to break really badly unless I'm on site. So I don't know what the hell I'm going to do. I've got to get that backup computer working, but guess what? I have more time now, thanks to NASA. All I can say is I'm glad it wasn't SpaceX launching this mission, because it would have been launched by now.
That will save you a lot of time.
Yeah. Yeah.
Yeah,
So,
at most SpaceX would have given you 24 hours or so.
Paul, is my son right? Should I be dumping splash top for tail scale for everything?
Well, look, they're not the same thing.
Oh,
Tail
okay.
tail scale is just a uh, an easy way of using WireGuard, which is just a virtual uh, private network kind of situation.
Okay.
If you want it screen sharing, um, it could you could use anything simple that runs on top of Tailscale. Uh, the thing to be aware of about Tailscale is that it's one of those services where it looks really attractive because uh, the first level, the free uh, consumer oriented level is really powerful until they decide that it won't be anymore. Um, if you really
So,
want to be free of that in the future, then use WireGuard and take over the maintenance of it yourself, which is not a big deal for a small organization. It's static, uh, mostly static configuration, and you know who's going to need access to what. The remote lab uses WireGuard because we built it before Tailscale was an option. Probably we would have used Tailscale um, if we had had the choice, just because easier for individual users to onboard with it. WireGuard is a mess. There's because the shared trust is manual, basically. So if when I add a new user to the remote lab, I have to add him. I have to take uh, a key that he provides to me and put it in a file. Now that's not a big deal for a small organization, but that's what Tailscale avoids. Basically, it automates that whole network of trust thing. Um, and as the pay, what you have to pay for that is that there's a cloud service you're using. And as long as they're free for your class of user, then woohoo, great. And it's easy and just works. And on the day when you can't use the cloud for whatever reason, um, maybe because they decided to charge you for it, then not so great.
well, in this particular case, we're using commercial software that we're paying hundreds of dollars for each user anyway. So we're not worried about paying Tailscale. I even looked at them, looked at the paid versions, and I said, I'd be happy to pay them $100 a year or whatever it is, or 300. No big deal, but I don't need to. The free version looks like it does everything I need. So if they want to change the rules and make me pay for it, I don't care as long as it's modest amount of money. Uh, I just need a new environment because SplashGuard changed the rules so it just will not work anymore at all. In a shared environment, they want you to be teams, and teams are all that you see, we have like if I have Splashtop for my company, I use that Splashtop to access DSES. Oh, wait a minute. Then somebody from a different organization wants to use their Splashtop to access DSES, and we start mixing and matching, and that's how it used to work. It used to work beautifully. Then they said, no, no new user can have the service that does that. Uh, any new user has to be a member of a team, and therefore a single user needs multiple paid licenses for different teams. Call it DSES, your private company, calls remote lab, whatever. You wind up with $1,000 a year instead of $100 a year. And I said, no, 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 you guys are completely off the wall with this. And they started that just a month or two ago with this new licensing. They said if you have the old license and keep renewing it, you can keep doing things the old way. And I said, fine, but that means we can't add a single new user to the system. And so I'm looking for a new way out. And yes, I need desktop access, not just command line access. So,
Well, the thing is, the solution to that is to separate the networking from the desktop sharing, right? So if you have some off the shelf desktop sharing that just relies on being on the LAN, like maybe what's built into the OS, and then a virtual private network thing like Tailscale, then you've got a working solution that you've cobbled together out of two separate things.
yeah,
But
I think so. What the heck is it? There's some of the computers down there that are using, God, I can't remember the name of it. It's some simple desktop sharing uh, application that is sometimes free and works across all operating systems, and it's not Splashtop. And I'm having a senior moment. I can't remember the name of it. But yeah, that's probably what I'd put on top of Tailscale. I'll figure it out.
yeah,
But we need a new standard mechanism. So you're using wire. Every place I go is using something different.
that's the wonderful thing about standards is there are so many to choose from.
Oh, yes. So there is none to speak of. But I'd like to have a standard across all of DSCS because there are 1, 2, 3, 4, 5. Well, there's at least 5. I think of right off the top of my head, computers that I need access to at DSCS. Plus, I got another 5 or so here. And I want access to my computers here when I'm not here, like when I'm down there. So I'd like to standardize all of that mess somehow. Of course, whatever I choose, there'll be a new standard next month. So
Well, the nice thing about Tailscale, aside from it being easy, is that it's based on WireGuard. And WireGuard shows every sign of being the way all virtual private network stuff is going to go. Um, it's just better than the old VPN stuff. So if you go buy a VPN like NordVPN, something like that, it's based on some rickety old protocols. WireGuard is more efficient, more modern, and it's completely open source. So that nobody can stop you from using WireGuard in the future. Uh, except there's always a possibility that the team falls apart and you don't get updates that you need for later OSs, but that's true of any kind of software deployment.
okay, so now we know what I'm going to use all this extra time NASA just gave me for. And Paul, you're in trouble because I may have to ask you questions.
Well, if you're
Right?
relying on me as an expert for this stuff, then you're the one that's in trouble.
Uh, well, you gotta take baby steps, you know. Right now, I know nothing. I just gotta list the names. I gotta go to their websites, learn what they are, try to figure out how to put it all together in something meaningful. And so I can kill my splash guard stuff or splash top. Splash guard, I'm getting them mixed up already. But that's where we are today. We're having fun.
Rick, this is Adrian. I had a quick question for you on the beacon that was used on the antenna for Artemis. Was that just a carrier, or did it have any modulation on it?
No, it's a carrier, but it's based on an SDR with a multiplier, and it has outputs before and after the multiplier, so it will transmit signals uh, that are up to I think 2 gigahertz from the SDR, And then at the 8.5 gigahertz for the deep space mission, it has the multiplier after it. So the
Oh,
multiplier
so
puts out about 400 milliwatts, and I think the SDR without the multiplier puts out, I think it's like 200. I believe there is
is that the
also,
same one that Alex put together?
well, that is the one
Oh,
Alex
for
put
oh,
together.
okay. So it has also the 2 gigahertz, 2.4 gigahertz output besides the 8.4.
Yes, yes, yes.
Oh, great.
And
Okay,
you have
thanks.
to
Yeah,
look, you have to look really closely for the other SMA connector, but it's there.
I see. Okay. No, I was just curious if it was just carrier that was being used, or if you're incorporating any kind of modulation on it, or
Well,
tone or something.
because it's an SDR based transmitter,
You could,
if
yeah,
we ever wanted to modulate it, I guess we could.
sure. Okay, great. Thanks a lot.
Oh, and one other thing, Michelle, you said you look, by the way, I kept saying 35 stations, there's 34 for Artemis, and you saw a friend on there.
Yeah,
Well, guess what? Uh, I have 3 friends on there,
right on.
one of whom saw me before I saw him. Uh, and you
What
might
in the announcement, you mean?
in the announcement, he saw that when it finally came out, he didn't know it was me until he saw the distribution list on the email from NASA, which had our email addresses. Then he saw my email address and he immediately sent me an email. And you might know him, Akim Boldhart
Oh, yeah.
in Zurich.
Mhm.
And so he sent me this wonderful email saying, "Why we haven't talked in a long time." You know, we had a lot of fun stuff going on back then, and he thought this was great, like old home day, and he was very pleased to see we were on the list. So that's nice. Unfortunately, his university only has a very small dish. But they're going to try anyway.
How small is small?
I think it's less than the 9 meters that NASA considers adequate. I think it's maybe 6 meters. I've got to go back and look at his email. But in any case, he was very excited.
Oh,
I
yeah.
thought that was great. And of course, my friends in Germany and others, it's nice to see that there are people you know out there in those 34 stations.
Yeah, it's a good group. I think it's really nice to see the response, and I'm looking forward to all the different results.
Yeah, we have way too many California stations, so
Well, that's where a lot of the folks that do this work, it's a very high concentration of people that do this sort of stuff are here in California. So not
that's
surprised at
true.
all.
Yeah.
Do y'all think that NASA kind of overestimated the size antenna that they really needed? It just seems to me that this kind of an overestimation
It
on the
is
size that they really needed.
Well,
at
given
least
that,
running the numbers, especially the previous numbers that Dr. Steffes came up
well,
with for that, and then comparing the stuff that and what Rick shared. Yeah,
yeah, I
I don't
mean,
mind them keeping the bar kind of high, but I don't think that you have to have a 9 meter dish
Just
to
to pick up a
crack the job.
carrier, I mean, gosh,
No,
no,
I
no, no, no,
translunar and
no. Be a little careful. There is there are like 5 different modulation types that they have told us about. And some of them are pretty wide and they don't have a distinct carrier necessarily.
oh,
So the fact that it's a 25-watt EIRP signal, if that were just a carrier, that'd be a mammoth signal, even for a 3 meter dish. But no, no, no. If they're transmitting uh, megabits per second and
oh,
there's no distinct carrier, the density of signal is pretty low. And they're going to be transmitting anywhere from tens of kilobits per second up to multiple megabits per second, and with slightly different modulation schemes. It's all cram stuff. So we can, if you have enough of an antenna, you can derive a carrier from that, but it's not as trivial as if it were a narrowband ham radio signal.
Yeah.
I see.
Even with that though, there's some good integration that you can do. So you can make up for a lot of that with some good software. I think that my guess is that the smaller stations are going to have better results than expected, and that the bigger
They
stations
may
will have
have,
even better results than expected. I think that they're being very cautious and conservative,
well,
and that is not
they're
surprising at all.
they're not they're not demanding high performance, but we are hoping to integrate over 1 second and produce Doppler data in 1 second intervals with appropriate timestamps. I don't know if you could do that with a 3 meter dish
I think you can.
if they're transmitting at high speed.
I think you can take a crack at it. It just depends on what, because there is a variety of things they're going to transmit. So you need to pick your battles and just design for the thing that you think you might be able to get.
And of course, they're not telling us
Right,
when they're going to transmit different modulation schemes.
right.
So you've got to always have your receiver
Yeah.
recording fairly wide bandwidth at all times because you don't know what they're going to do when.
Now, hopefully, like they would eventually say, "Oh, by the way, we were transmitting the signal that you think you have a crack to can handle during this hour and a half." I'm hoping that it would eventually be communicated so that you could then go back, assuming you recorded all of this. Um, these are a lot of assumptions, though.
Well, there are some pieces of good news. For example, the data we record is owned by us. And we can publish it and use it in any way we want afterwards. But the correlated data, that's not. That's I don't know whether they're going to publish that or not.
Guess we'll have to see. A very
Yeah.
exciting project that has, excited a lot of people around the world. I think that good things will happen.
Yeah. So
Speaking of,
I'm very encouraged by the number of stations that have applied, because I think quite a few more applied than were accepted. And I think there's going to be not 30, but hundreds of stations that are not officially uploading their data that are going to nonetheless be publishing results on their own. And that's just fine. NASA thinks that's fine. I think that we'll learn a lot from that.
Yeah, the best way to learn this sort of stuff is by trying it, really.
Yeah.
Because you can plow through all of this math and these difficult books, like we were talking earlier about the Gardner book for, for control loops and like PLLs and costless loops and things like that. And you could slog through the math, and it is hard going for people like me, and you can get a grip on it, but wow, it really becomes clear when you actually build something and try it. And there's a whole other universe of then learning, um, and that's really where it starts to really you really own the concepts, and they start to make more sense when you can see it. So being able to tackle a really cool, essentially interplanetary, communications challenge. This is just a wonderful opportunity, and I think that there will be a whole lot of learning and, with modern computing and modern memory, we can make recordings. So even if you weren't able to make it happen, these IQ recordings out there, that's going to be an additional
We,
asset
we
for
are,
open
we
community.
are planning to record the IQ data at DSES.
It adds up
That's
quick
it.
though, as you found.
That can be a lot of data.
Can be a lot of data. It's a because
Uh,
it's not. This is not like just a couple of hours. You know.
10 days.
Yeah.
10 days of IQ.
well,
Wow.
it's not, it's not that much because first of all, you gotta figure how much of that 10 days is in view. And you
Right.
can get a rough estimate of that just by looking at how much of the 10 days the moon is in view.
Yeah. But
That's
this
not
is a lot of
exactly
time.
the same, but it's
It's a
close.
lot. It's a lot of time and tracking, and
Yeah.
it's a
But if
marathon,
you're recording
and
like,
not a sprint. So it's
well,
different than the like Eve challenge where you got a pretty limited window. And this is so much more of a endurance is
oh,
required.
by the way, Eve is back on at DSCS. And Ray pointed out to me yesterday, he said, Venus just went behind the sun. It's
Yep.
on its way out.
Yeah.
It'll
We're
be
halfway there.
here. It'll be here in October. So we got to finish up this Artemis stuff so we can get back to work on a better Eve.
Yeah. Well, we got the
And
proposed protocol ready, pretty much ready to go.
well, I don't know if you saw it, but the there was an experiment that I can't believe they did, Roger and Alex. Roger built an entirely new frame for mounting packages in the feed of the DSCS antenna, and it's absolutely a work of art. And it's so much better than anything we've ever seen. And we put that up there, and there was some difficulty with the steering, or not the steering, we're trying to focus. And Alex was concerned that the predictions were 15 dB off from what we thought we should get with the beacon. And so he did something crazy. He did a drift scan of the sun. Well, it melted the antenna of the feed, as you might expect. That particular feed had rings around it made out of PC board material, and it burned it. But the good news is that it showed us that the feed was in the wrong place.
Right.
The burn was on the top section of the feed for 2 gigahertz. And so they said, oh my God, we need to move the feed up, maybe 6 or 8 inches from where it was. Well, I would never have pointed the damn thing at the sun, but he did.
It's a little interesting approach there.
It's a scary thing to do.
Yeah. Okay.
Just, but it did melt part of the antenna, but I think it told us something critical. And Alex and Roger are going to have to do something to move the feed up. And I'm not quite sure what that is. On most antennas, the struts that hold that are adjustable, but I don't think they are in our case. I think we're just going to have to deal with what we got and move the feed up 6 or 8 inches, which is a lot. it wasn't so much when we were doing pulsars at 1.6 gigahertz, but as we keep going up in frequency, it matters more and more.
That's right.
Could it have just been a misalignment on the pointing towards the sun?
I don't think so, but right now I just listening to what Alex and Roger had learned, and I'm going to call Roger and see if I can find out more uh,
Well,
this week.
good luck
I
with
mean,
that.
if they misjudged the transit, I mean, it's only half a degree. I mean, they could have missed it by a little bit, and then the focal point would have been off a bit.
That's true. So yeah, there's a variety of causes for that, but we'll see.
Yeah,
We may
okay.
need to make another trip down to Haswell now that we got an extra few weeks to try to resolve that problem. Somebody was talking about in an email this morning. Uh, there was an article that they found about using a laser to map the dish and to try to find out where exactly everything should be.
Well, I saw that, and
Yeah, and I looked up,
you might recall we did some work about a year ago
I
with you
know, I
guys,
know.
and that
Don't
still hasn't
don't
been.
have to remind me,
It's
but
much easier than using a laser.
the particular laser that was used in that article, I have one.
Yeah, you'll get better
In
results
fact,
with the photography.
mine's better than what they used because this is a green laser. They used a red laser.
Okay, you'll get better results with the photography.
I can see it better in the daylight.
Sure
That's for
can.
sure.
Yeah,
Uh,
you'll.
so I said, "Oh, okay. Well, I got one of those. If they want to, if Alex and Roger want to take this one up on the dish, I'll be glad to donate it to the cause." I have no idea whether they want to do that. Alex never did the plan that you put out that he said he would do, so I'll have to ask him what he wants to do next.
That would be good to know.
I think it's really important.
Yeah, I thought so. Um,
Well, the good
uh,
news is,
it's a
even
little
if we're down
weird.
10 dB, it won't matter. Our predicted signal to noise for Artemis is in the 45 dB signal over noise.
Yeah,
Even if we're off 10 dB, I'd rather not be off, but we're still going to hear Artemis.
yeah. I think that you can say that with a large degree of confidence that, and also then when you do hear Artemis, then you have, another data point of like, oh, this was the expected SNR. This is what we got. And there's some other things that you can do, looking carefully at the signal, and then you'll have a lot more information on dish performance.
The only thing
Not
that
always good.
bothers me now about Artemis is there are two NASA engineers who are just recently retired engineers who are putting up red flags saying this is not a good idea.
You mean like the whole thing isn't a good idea?
Well,
Or
they're saying they should not be launching people at this time. And they
oh
have
wow.
some pretty good arguments that are a little scary.
Well,
Oh.
Orion supposedly has a really questions as to the heat shield. That heat shield supposedly might have some defects
Yeah,
for
I
the
saw
lunar
pictures of the
reentry.
heat shield on Artemis 1, and it did not look good.
No, it didn't. It did
And you
not
would
look good
think they would
on
want
the
at
first picture.
least one unmanned mission where the heat shield survived. But, well, I don't know.
Well, if the Boeing Starliner came back, sorry I brought that one up.
Wow. Yeah, no, I mean we tend to focus on the radios and the proposal that we have in front of us for tracking, but yeah, I no, I did not see I'm assuming that the retired engineers are saying this publicly and that they're
Oh,
writing
yeah, it's on
publicly.
YouTube.
Oh,
Yeah,
wow.
just
No,
go to
that's
YouTube.
the broader concerns with the safety, crew safety and all are way more important. That's true. So
A lot
I
of
didn't know
people have
about that.
brought up the heat shield as a potential problem. Yeah.
Yikes. Okay, well, it might get more
And
complicated.
then anytime you see a picture of the inside of one of these capsules and compare it with the inside of SpaceX capsules, it's like, why are we still operating with 1970 technology? SpaceX is not.
I don't know. I guess they probably have sets of assumptions and some sort of design process that's different levels of baggage, different levels of culture, um,
Yeah,
all sorts of different reasons that I can think of. Um, yeah,
yeah,
it is different visually though. Big difference in the from the crew's point of view.
yeah. The SpaceX capsule looks like a Tesla.
No, it does. I remember lots of like flat screens and
Yeah,
pretty.
that it was it. Some really comfortable chairs and some flat screens, and they were touch screens, so there's no knobs, and you just touch the screen. And I said, "Wow, touch screens that can survive that kind of vibration and G forces. Those are pretty good touch screens. I'd like to have one of those."
Yeah.
So, yeah, I mean, I think that's why Elon hired 20-year-olds instead of 60-year-olds to design all of his stuff.
Well, why not both?
Uh, I don't know.
You get the best. I think you get the best designs if you can have a truly diverse team. And I mean, the traditional sort of things that we talk about in terms of diversity, age and experience and background and cultures is another source. I think there's some pretty compelling reasons to have knobs and levers and switches, physical switches in something like
Well,
a spacecraft. But
as you can see from my DSCS console, we have a lot of knobs and switches.
yeah, sometimes, organizations of the size of like us and DSS, there's like you run with what they brung. So if you get somebody that's donated a lot of equipment and it happens to have a lot of knobs, then that's what you use. If you get a chance to invest in if you get a blank paper design, like we had the opportunity to design remote labs, and it is not it's not as heavy on the knobs in traditional switches as it would be if we had taken San Diego
Mm.
Microwave Group equipment. Then we would be running with a older generation equipment, I'm sure. But because we wanted to design a remote lab, then it was accessible, a remote lab bench. This meant that the equipment that we got, that has a lot more screens on it
Oh,
and
yeah.
it's all network accessible. So it does make a difference when you're able to kind of like back up, start over, or if you have a different set of assumptions. Like I got to tell you, after sitting in the remote lab, it's hot and small and can be uncomfortable, and there is not a whole lot of space for the human in there, and that's the way it was designed. So if you were starting over and you wanted to have a really comfortable lab bench, like I'm sitting at one right now in my place, and there's plenty of space here for me to spread out, and I can then log into the remote lab and get those features. Um, but you can't really replace to be able to hook up all the plumbing and the when not if but when things break or lock up or get wedged, then someone has to go and turn it off and on again, and that's the real
You
secret
just
for getting
you
things
just
to
hit
behave.
you just you just hit an important point. Uh, I don't remember whether I asked Paul for access to the remote lab or not in the past. But if I did, I forgot how to do it. Uh, if I want some additional experience that I can use in designing a better way to remotely access DSES, I would like to get access to the remote lab and play with it and see how it works and see if I can take that learning process back in part to DSES. So that would be another thing I need to put on my list.
Well, all the documentation is available.
Yeah, I saw the documentation. I should have no trouble doing it.
Yeah, you just
Speaking
need
of
time,
equipment,
right? Oh, sorry, go ahead, Adrian.
I just had a quick question. Has anyone heard of an RX 888 SDR?
Sounds familiar.
I have not.
It's just something I ran across the other day, and apparently it's a fairly simple SDR that can give you up to 65 megahertz of bandwidth, and it's like for like under $200, and so you don't have to go to like a B210 or something to get that kind of bandwidth.
Oh,
And I'm just wondering if you guys had ever heard of it. A lot of the people that do the DSN stuff, where they need to buy a large bandwidth to try to pick up the different probe 8.4 gigahertz transmissions, and because of Doppler shift and all that, apparently use this. And so I was just curious if anyone had heard of it, had any experience. It sounded like a cheap way of getting 65 megahertz of bandwidth. That's kind of what I'm looking at.
I'm not convinced that it has 65.
They
I'm
claim
looking
that.
at it. It goes, it tunes from 1 to 64 megahertz. But what
Well,
bandwidth is it?
the way I understand it, it's almost like a two for one. So you have two inputs. One has a regular, what is it, R820 whatever SDR chip on it, and it goes, standard uh, 10 megahertz bandwidth. And then the other input basically just goes directly into the A to D, which is the one that has the 65. So you have to provide a front end that brings you down to some kind of an IF down to somewhere within that 65 megahertz of the bandwidth. Is the only trick to it. So you can use the direct input to the AD, and then just basically and then your computer does everything else.
Yeah, okay. I see. Sure has a lot of heat sinks on it.
They say that A to D chip runs really hot. Yeah,
And it's $300.
I've seen it. There's a site that has it for 150.
Okay.
So at least if you can get a signal down into the 65 megahertz range, you can get at least well, if you put it right dab smack in the middle of it, at least you got 30 megahertz one way or the other, which is already beats anything that a Pluto or SDR play. You'd have to go to like a B210 or something to get anything much more uh, than the standard 10 megahertz. Anyway, I just thought if you guys had any experience with it, I'm just kind of looking into that as a possible kind of wide bandwidth way of screening for signals that are kind of maybe up there in the Doppler shift range where you're not exactly sure where you're going to find it. I think a lot of the people that do the Mars, uh, a lot of the orbitals and stuff, orbiting probes are using it for detecting those signals.
Oh, cool. Okay. Well, are you thinking about getting one or do you have one
I
already?
was thinking about it. Yeah, I mean, I can go 150. 300 starts stretching my budget
Yeah.
with being retired.
Yeah. Well,
Yeah,
if you do get it, I think we'd all be really interested in your review.
so AliExpress has it for 160.
Yeah.
Amazon has it for 300.
Yeah, well, Amazon, it's not going to be the cheapest price, but anyway, I just ran across this the other day, and I thought, wow, that sounds like an interesting approach, uh, to get pretty good bandwidth to screen out for a signal you might not know exactly where it's going to be at, especially if you're trying to do any kind of DSN stuff.
I'm a little confused by this website that has it for 150. It looks like it's classified as an add-on to a Hack RF.
They have other things on there. I don't believe it's the same. I don't think it's the same one. Is that the open source something or another?
Yeah, open source.
Yeah, that's the one
Yeah.
that I was looking at. Yeah.
That's
They
the
sell a bunch of other stuff too. I don't believe that's the same SDR.
I followed the link from the RX88 888.com website, which seemed like it ought to be the right place.
Well, I'm not totally familiar with it. I just kind of ran across it the other day, so I haven't really had a lot of time to research it. But just at first glance, it sounded like a potential kind of cheap way of getting that kind of bandwidth. But um, I just thought maybe you guys had more experience. Maybe somebody had heard of it.
Yeah.
Sounds like Paul's heard of it. I had not.
You know,
So I'm not familiar with it
Okay.
at all.
this is this
All right.
it rang a bell, but this thing that I'm finding here is not the same thing I thought I was remembering. So I know nothing except what I'm reading right now on the web.
There's so many choices out there.
Well, yeah, but
There's so much.
some of them run into real money.
Yeah. Oh, yeah. That's true. Like, the one I think that the workhorse SDR for us in the lab um, has been well, I guess the Pluto SDR is a workhorse, maybe a
Yeah.
maybe a work pony, I don't know. But the workhorse SDR for us in the lab is the EDIS B210.
Yeah.
Fantastic SDR
Right.
for working in
That's
the lab. And back
yeah.
when we got ours, it was I I want to say it was a little over $2,000. So like
Yeah.
order of magnitude more money
Sure.
than these like the ones you're talking about or the HackerF or the Pluto or whatever. And now the B2 to get a B210 I think it's substantially more than $2,000. So they've gone up in price. You can get them off of eBay if you're lucky, and there are some sort of B210 type of clones. But what
Right.
you're paying for is a larger FPGA, and you're paying for much higher resolution, better
Right.
clock. So there's a lot more stuff in there, and it's a really good design. So
Yeah.
solid SDR. Um,
Well, I bought one of the DSCS has two B210s, real ones, and I bought a Chinese knockoff for, so I don't remember, $750 ish. Still pricey, but not $2,000. And our tests have indicated it is 100% compatible
Hmm.
in performance uh, and and other ways. And it actually has one or two advantages over the B210 because it brings out some additional pins to the outside. So that's what I'm using for the backup system. We have a real B210 for the Artemis in the feed. But if anything goes wrong, like Alex points at the sun again, uh, with that feed in there, the backup system is down in the control center, fed by LMR 600 coax, so with a preamp in front of that.
Yeah.
Uh, so we're going to go both ways, and but we're basically using two B210s for this. We'll really have side by side comparisons then.
Well, that's lucky. I got kind of burnt not too long ago on trying to get a discone antenna out of out of it might have been Alibaba or one of those places, and I got I had an old I had an old one that got knocked over out of the tripod when we had those big windstorms here in California, and it snapped off several of the radials. So I tried to get a replacement, and What a joke. The center radial, which is for the lower frequency on the antenna that has the loading coil. Uh, there was no connection between the radial and the base of the antenna. And when I took it apart, it had kind of like a steel spring on the inside instead of a loading coil. And it wasn't
Oh,
even making contact between the radial and the base of the antenna. So I'm having to redesign now a loading coil for that center antenna on it. So anyway, it's just really got burnt on that one for almost the same price as you would pay from uh, from the ham radio shop or something. But anyway, uh, yeah, it's kind of leery getting the stuff out from China. Um, so anyway, I guess you lucked out getting that clone that seems to
well, I
work.
didn't get the clone from Alibaba there. I can't remember the other GPS, yes, the other site that had all the
Oh,
SDR.
okay.
They're still China, but they're a little more reliable.
I see.
Anyhow, that's enough for one day.
Yep.
Think I'll go back and find out what's wrong with my Python program.
Yeah, good luck with that. We have nothing but empathy. This is, there's an interesting way of looking at software. A lot of people look at the development of software as if it adds value, that it's an asset, and the more software you have, the better. And several authors have tried to argue the opposite, that software is a liability. And when you write software, it instantly starts a maintenance clock, and everything is ticking kind of against you. Things can shift out from beneath you. There's bit rot. Frameworks come out with incompatible versions. Protocols change. OSs suddenly decide to dump everything into a seg fault. It's chaos. So if you get into your mind that software is a liability, all of a sudden it's like, oh, the less software, the better.
Oh yeah, yeah.
which is which is kind of unfair for those of us that
No,
really love to write software. But it just software as liability is a thing, and then it also starts making a lot more sense. When you're battling the bit rot and just trying to it feels like you're trying to get back to where you were, and it's a lot of work just to
that's
get back to where you were, and you want to move on
that's
to the
right, right.
next
This software
phase, right?
worked last week.
Yes, it worked
Al-
last week or last
Also,
month or last year. And so just when it feels like 90% of your workload of your task list is to get back to where you were, it can make you a little grumpy. It really
I'm
can.
yeah,
I'm hearing I'm hearing all these horror stories because I don't do much software, but I have a little bit of software uh, in Arduino stuff. And now that Qualcomm bought Arduino, I'm hearing that some of these libraries might disappear. And I'm going like, what the heck? You would have never thought that for Arduino, and now even that is maybe at risk.
Well, it's
Uh,
a,
with,
that's
with
a, and that's a whole other. Oh, go ahead, Paul.
Oh, I bought one of those Qualcomm Arduinos, and
oh, did you?
they
I mean, I
are
just have some of the old ones, but I mean, now for any software, they're saying maybe some of these people might be taking their libraries down because Qualcomm is saying that they own that property now, the the
that's a
the
that's a
the,
variation I
the
haven't heard, but
intellectual rights.
that that's not how open source works.
I know that's what everybody's saying, but apparently Qualcomm's trying to do something different and saying that now it belongs to their intellectual property. Uh,
well,
anyway, I'm
just
not
be
sure what the story is.
just because you heard Qualcomm's doing something doesn't mean they are. People start these little rumors and they get carried out of hand. So we'll
Well,
see.
I hope not.
But my thought was, why don't I just take this Python program and throw it at ChatGPT and ask it what's wrong with this?
You might have to have a slightly longer prompt than that, but that's a valid thing to do.
Is that
Python
true
is
that
one of the things that
Claude
it's really good at.
is it true that Claude is better at software than ChatGPT? I don't know. That's what I was looking at the other day.
I would say absolutely yes.
Okay.
Having used both for for trying to write software, and in both directions, to try to evaluate software that I'm not familiar with, and also to construct high quality software. There's a clear difference between ChatGPT and Claude.
Well, that's good to know.
Consistently better results with Claude, and just the tone, like working with these two chatbots. Claude's easy to work with, and ChatGPT annoys me.
Great. I'll keep that in mind. Fantastic. Wow.
I've had
Great
a,
stuff.
well, I've asked ChatGPT a lot of questions when I was trying to repair the rubidium and the spectrum analyzer, and it gave me wrong answers 80% of the time. What I found, where I found the right answers was just type it into Google, and it gave me the right answers. And I said, well, what the hell's going on here? This is supposed to be hot stuff.
Well, that's an easy answer. It's the size of the training set. There's a
Yeah.
huge amount of Python on the web that the thing can train on and has trained on because it grabbed everything it could get its hands on. Not so much on debugging rubidium oscillators.
Well, that's true.
Yeah, I
But
think
I
we
mean,
found
I
same.
asked a simple question like, what size screw goes here on this rubidium? And ChatGPT gave me the wrong answer. It should have said, I don't know. And Google
Yeah.
gave me the
Not programmed
exact
to
right
respond that
answer.
way. Yeah.
Google
Right.
said, you use this screw with these threads, and it fit.
Yeah. Yeah. This is, we're all going to have to get used to this and to figure and to learn how to use the tool. Because, yeah, Paul's right. They're not going to admit when they don't know something, because then you
Well,
might not pay for it.
Yeah.
It'll very
So,
happily tell you something that sounds very confident, but is very wrong.
so this,
And yeah, the
this,
training set is really important. Like when asking about Python, you're going to get some very high quality answers, because the training set for Python and the scraped, arguably completely stolen code that it's used to train on, there's lots of it. And the design patterns for Python have developed over time, and they're pretty clearly, you can clearly derive them from the training set. For something like VHDL, there's just simply not a lot of examples of that published open source. The vast majority of VHDL code, I would say, all proprietary, not ever going to see the light of day. And so it's feels like it's not as good coverage, although I've gotten some good results in working with it. And it's very readable and can help you. But the interesting thing about even Claude, who's very, very good at code and helping you with code, is that you have to constantly remind Claude what the differences are between a hardware descriptive language and a general purpose processing language.
oh, yes.
Scripted language, you have to remind Claude that this is a hardware description, and these are the assumptions that you always have to keep in your mind, that when you have a result, that's from the past. When you are going to deliver a result, that's going to be in the future. The idea of a clock and everything is synchronous. So if you're writing VHDL, which all VHDL is written for synchronous digital logic, Claude can make some mistakes, slipping into the mode of treating it like this is a general purpose processing language, and that your results are immediately available when they're not. They're going to be posted in the next clock, or so that is something you have to kind of watch out for. So you have to be the subject matter expert for using it in a situation where the training set is not as deep.
So what website do I go to jump on the Claude bandwagon? I see too much.
Oh, Claude.ai. I think
Claude.ai?
yeah, let me make sure that that's right.
That's one of them.
Yeah, Claude.ai is the official Claude. That's the web interface. You can get Claude in other ways too, but that if you want the chatbot version, then that's where you go. Claude.ai. Cool. Well, it sounds like
So-
you're off to go defeat your Python dragon there, Rick.
Oh, yeah.
Tame the
And
dragon
then-
yet again.
Then I've got to look up Tailscale and UV and WireGuard and Claude just from this conversation.
Well, we aim to please. We got to
Yeah,
keep you
thank
out of
you.
trouble, you know.
I'll
We
be
got to keep you
busy.
off the streets, man. We know. We know you. All right. Well,
Oh,
let's close here, and then
Okay.
yeah, hopefully we'll see you again next week, Rick, and you can tell us about all the progress, and Adrian maybe can tell us if you decide to buy that SDR or if we get the other things kind of
Sure.
sorted out. And yeah, looking forward to talking to everybody again. So yeah, some
Good
good
deal.
news from everybody, and hopefully we'll have even more to report next week. We're gonna really hit the interoperability pretty hard and get the software modem properly published because the repository is in a little bit of disarray with all these experiments. So, like the README doesn't match, and I think Matthew found a problem with the capitalization of the README. And anyway, there's about 9 different C++ files, but only one of them is really working. So, the usual disarray of a repository. So that should all be fixed in short order. Get it nice and clean and a good README that doesn't cause any heartburn for Mac users and et cetera, and so forth. All
Great.
right.
Well,
See
everyone have
everybody
a
real
good
soon.
week.
Thank you. Yeah,
Everybody
you
have a good
too.
week. Bye bye.
See you soon.